All right, good morning, everybody, and welcome to the 2019 Capstone NDSU presentations. We are the NAU Country group, and we'll be kicking it off here. So, a little bit more about ourselves. We are a group of 4 NDSU computer science students. I'm Aaron.
I'm Jacob.
I'm Clint.
I'm Jordan.
And we're all seniors here in the computer science department at the university. Now, our sponsor, NAU Country, the project sponsor we've been working with is Joe Hoffman, who appears to be running a little late, but hopefully he can make it here towards the end of the presentation. And for a little more technical support and helping with our programming, we were assigned 2 project mentors, Dave Bruley and Brad Brazel, who we've kept in weekly communication with throughout the semester just to help with design and technical issues that we ran into. So more about the company now, NAU Country. Their main office location is located in Ramsey, Minnesota, and they have offices actually throughout the entire United States. Their information technology department is actually located here locally in Fargo, so that's kind of how this whole project got started here with NDSU. And what NAU Country does is they are a crop insurance agency, so they work very closely with farmers to give them grain estimates and grain quotes for insurance. And this will bring us into the opportunity here that we had working with NAU Country. The opportunity falls along the lines of the claims adjustment process. Now, this process is how NAU Country gets the information from the grain bins to be able to accurately give quotes for insurance. Right now, the whole process is just not really ideal. They're using paper forms to fill out all these grain calculations, which can get very tedious. To make it more difficult, there are actually several different types of grain bins. As you can see on the left, the top left is a round bin. Below that is an instance of a flat storage container. And to the right is another type of container. And all of these different containers have different calculations in order to find the total volume in the grain within them. And that can be pretty difficult without some sort of technology involved. Another issue here that NAU Country is dealing with is the data is not centralized on these forms. So it's hard to access, and for example, searching through it could take a decent amount of time compared to if a technology were to do it. And the last opportunity here working with NAU Country is along the lines of data loss for that claims adjustment process. The information recorded on these hard copy forms, for example, if they were spilled on or dropped and lost, that information is not backed up in any way, so it would be permanently lost. Now that you guys know a little about the opportunity, I'll introduce the solution and how we went about dealing with some of those problems that NAU Country is facing. So the solution can be split into 2 major components. The UI, which is the user interface, and then the data management half. So for the user interface, we're using an iOS application, just your standard app. And we made that using Xamarin Forms, which is a .NET platform. And this allows for .NET to be used on an iOS application, which is what a majority of our programming is in. Then for the second half, the data management aspect, we connect that app with Esri's ArcGIS Online, which is a geographic information system. This helps deal with the plotting of points, mapping of points, and the actual storage of the information that we collect on these grain bins. So now you guys know about the solution that we're dealing with here. I'm going to let Clint take it away and talk to you about how we actually implemented this.
All right, thanks. So here you see a timeline of our project for what we projected to do to complete the work. On the left, you'll see the 2 colors that represented the first half of the semester, And we completed those items on time, and that included the basic framework of the application, as well as connecting and integrating with ARC. So we could authenticate user logins and pull down a map page, as well as create and read records from ARC. The second, on the right, the second two colors are the work that we've done since midterm to finish the project. A lot of these items did not meet our initial targeted deadlines. They proved to be a little bit more complicated than we initially thought. For example, our initial plan for storing a photo of the grain bin, we were planning on using storing on ARC a URL to a third-party hosting service like PhotoBucket. But we later found that ARC does support storing attachments for records, and you can store as many files as you wish in that field. And we also implemented the attachment feature for our year-to-year service, which we thought works really nicely. We're storing, each record can have multiple years of grain information, and we're storing that as a JSON file, which we could easily create another process to extract that information and create reports or store in a different location. Even though we didn't finish things exactly when we planned, we were still able to implement all of the things that we planned. So that brings us into our accomplishments. We did, number one, complete all of our goals for the project. Our application supports all of the basic create, read, update, delete operations for the grain bin records. Each of those records has shared general information, things like the identifier, image of the grain bin, what type of grain bin it is, and then there is type specific, as Aaron kind of pointed out earlier. There are multiple types of grain bins, so our application supports each of those types of grain bins, as well as each grain record has multiple years of grain, what was stored in the grain bin. We're also automatically calculating the volume of the grain bin based on the measurements that is captured in the grain record. And we're plotting those grain bins to their location on a map. So some of the things that we thought were really cool that we were able to do, we implemented the device's camera, and we're able to take a photo and store it directly to ARC and not have to use multiple data sources, as well as taking the location from the device and using that to plot the point on a map. Searching, we implemented, ARC has support in their SDK for searching, and we did multiple types of searchings. So we found it made it a lot easier once we had multiple records on our data set to be able to search for them. Really made things a lot easier. And then to finish things, the last couple of weeks we had a strong testing effort where we all came together to make sure that all of our separate pieces tied in with each other and worked as we intended. So that summarizes what we accomplished, and I'm going to pass it to Jacob to show you what we were able to do.
So I'm going to talk about the actual demo of our application. We're just going to go ahead and step through a standard use case and talk about some of the features that we support. Just 1 second here as we switch to the video. So first thing you see is our main screen. It's fairly basic, but it serves its need. The employee number here is something that can be entered to track who is the individual that is going to be performing the operations within the application. So that can be any free text field at this moment. NAU may choose to restrict that to a further domain. For the username and password, this connects directly to ArcGIS. This is the account that all the information and the mapping functionality is stored under cloud services provided by that platform. So after successful login there, we see the main menu. Again, basic, but it fills the needs that are required. And really, we try to keep it simple, make it clear. The new entry and a map view. So we're going to go through both of these processes, starting with new entry. So new entry immediately opens up the camera. You can see here the camera's being adjusted to take a picture of this bin. It's been taken. Now they can choose to either retake it or use the photo. Use photo is selected, and now we land on the first new entry page. From here, an identifier and a bin type are required regardless of the next actions you can choose, which I'll talk about in just a moment. The identifier is just a unique ID that can be written down. Maybe one adjuster wants to pass that ID to another adjuster for a quick lookup. And then the bin type is required right away so you can know what is the type specific of this bin, so we know to pull the correct forms later when trying to view this bin and edit its specific records. So I'm going to go ahead and step through that. So we'll assign an identifier of NDSU final. And the bin type, we're going to pick round storage, which is representation of what the photo is in this case. From there, we hit continue. The save for later option that you saw a second ago, that option can be used when you want to just save this bin, save the photo, save the location, and that identifier and bin type info, and just be done with it. Maybe you have further bins to enter. Maybe you need to leave the location you're at and get back to the office, and you're planning on filling out the information at a later point. For our demonstration today, we're just going to go ahead and do the continue option, which lets you fill out all those fields immediately. From there, now you see the general bin information page. This is the page that was spoken about previously that is shared between all bins regardless of their type. We display what the bin type is at the top just as a reminder to the user, and we'll go ahead and run this and just show some example input that can be entered for information that's stored on any bin regardless of its type. You can enter a note. This note can be whatever you like. Maybe there's a specific deformity in the bin you're taking a picture of and you just want to note that, that was noticed and it's been recorded. So from there, we'll go into capacity. This information here is specific to this bin type. This is a round bin, so that requires for volume calculation a radius, a wall height, roof height, hopper height. And this will be different for every type of specific bin that you select from the options that are available. This one doesn't have a hopper, so we enter 0. We go ahead and go back, and now contents. Contents is a page that allows the year-to-year record storage. This is auto-filled with the current year, in this case, 2019. If it's not, if there's already an existing record for 2019, it'll be decremented to the year prior to enter previous years if those haven't been recorded yet. So here we're entering specific information for the grain that is inside. These can potentially be quite a bit of fields depending on how specific you're trying to get. Also, the total grain volume is displayed at the top of the page. This is constantly updated depending on the input that is entered. And that is also recorded as a value in itself when this is saved to the Arc platform. Total deduction volume, that could be in the case that there is a some anomaly to the specific bin you're recording. Maybe it's just not a standard bin. So it's easier to calculate assuming that the anomaly is not there and then at the end provide total deduction volume. That just removes that, or it's mainly a note for the person looking at the record to remember, hey, this bin is potentially a little bit different. On top of that, you can enter a note specifically to this year-to-year thing. So maybe that's a note highlighting something like total deduction volume in the case that it exists. So from there, we're going to go ahead and hit save. This is now compounding all that information, preparing it to be stored on the ARC platform in the different forms. This is including the photo, that year-to-year record, general information, the type specific. It's all compounded into one saved location on ARC. From there, we get a success message that is successfully added. That's the new entry process. I've kind of gone over that. We're going to go ahead and step through the map view. The map view is, well, to kind of start off for what you're seeing at the moment, the red dot is a symbol of current location. That constantly updates. If you walk around with the app in your hand, that location is going to update as you move. Here is the bin that was recently added. From there, you can see that its information's loading. The picture shows up. You can make sure that you've actually selected the correct bin. It shows our bin type, round structure, and then the general information. You can also see created by NDSU test. That was the employee ID entered at login of this session. Modified by is blank because this record has never been edited yet at this moment. However, that will be in just a second. So this is our standard view. This is after you have a record. This is how you can go see it. We can go into history, and we can select any crop year we want to see. This bin only has 2019. You can see that information. You can see the total volume that was calculated previously. It's saved. It's recorded. Capacity. This is going to be those bin type specific fields. You can come in here, view them. Edit makes all of these fields editable, other than a few select ones like the created by. You can edit anything you'd like in here. You can also edit the capacity and the year-to-year records, which will be shown in a second. So here you can see that auto decrementation of 2018. It's going to be either the current year or year -1 for whatever existing records. So if you had a 2019 and a 2018 record, you come into this page, it's going to be pre-filled with 2017. However, it can be selected, which will be demonstrated in just a second here, to pick a year that already exists. You're going to get a prompt. This prompt states that it already exists. Do you want to edit this year? Yes, we do. We can see all that information is now filled. We're going to change grain height from 9 to 10. You can see that reflects the total grain volume up at the top. It's going to be saved again. And we'll also edit the note just so it's a little bit easily seen that this edit is sticking. We can go ahead and save. Okay, been successfully edited. Now we can see that that modified by field is also populated. We're the same user that initially logged in, so we both created it and we're the most recent user to modify it. Again, seeing the history, we see the total volume is updated there. We can see that the note is edited now. That concludes our process of managing bin data. Now we're going to go ahead and show our search functionality. So that toggles the search, little crosshair bottom left. And first we're going to search by an attribute. So we're going to pick bin ID. This is the identifier that is initially set when a bin is created. Ours was NDSU final, so that should be pre-filled here. Or we will fill that in. Hit search. That bin is now centered over the map and it's selected for us. We go ahead and click that. We will see that its identifier is in fact NDSU final. We can also search by, we're deselected it now to show that it also is able to be searched by other feature attributes. We're going to search by created by. We're currently logged in as employee ID NDSU test. Search. Again, centers it over the map. Selected. We know that NDSU test created that record. Another searching feature we've implemented is searching by address. I'm just going to go ahead and type in Fargo, North Dakota. You see we're getting some autofill options here, kind of help you decide what you're looking for. That's centered us over Fargo and map that point green. Now you know that that is the actual exact address that is considered Fargo, North Dakota. There we can open search menu again. We can clear that point. We want to make sure it's not covering any bins or whatever else. If it's just disturbing you, getting rid of it. And our last feature on the map is that you can refresh the map that was just done there. If you saw that quick blink, maybe an adjuster made a change that you want to make sure you can see. Hitting refresh is going to pull all that information from ArcFresh, and you're going to see everything that's most recent. That concludes our demo. I'm going to hand it off to Jordan to speak about our issues and risks.
All right, so some of the risks that are involved with our application involve internet access and mutual exclusion. So there are some grain bins in some fairly remote locations, and in order to save all that data, we need to have access to the internet to save it up to ARC. So that can cause an issue there. So another thing would be mutual exclusion. So as it currently stands, there are we allow 2 people to edit the same bin at the same time, which basically comes down to whoever saves their information last will be the data that is actually stored in the end. So say the first person would save theirs, then the second person, when the second person saves theirs, it is overwritten the first person's information. So those are some of the issues. Looking back on what we've learned throughout this semester, we've learned collaborative development. So things such as merging code together, trying to resolve conflicts in our code, stuff like that. We've learned better communication as a group, resolving conflicts within the group. And we've also learned to adjust to adapting requirements by our sponsors as well. Another thing we've learned is some mobile development challenges. Not all of us have had experience developing with in the mobile development field, and but we've overcome some challenges, and we all have decent experience with that now. And along with that experience, we now have experience with GIS as well. So moving forward, some things that could be added to this application would be to develop editing restrictions. So that goes back to the mutual exclusion. If you were to set a flag or something that would only allow one user to edit a bin at a time, that could solve the whole mutual exclusion risk. Another thing we could add is to adjust the user preferences, adjust the user interface to user preferences. And so this application has not gone through any actual user testing with the users who will end up using it. So we could adjust the user interface to be more to their liking, to how they think the app should flow. So another thing we could add would be we could improve the map point clustering. So we currently have that implemented, but it could be improved. And we can also add multiple bins at once. So while we were actually making our final video for this class, we noticed that quite a few times, or actually fairly often, there are a lot of bins right in a row that all look the exact same. So they have the exact same wall height, the exact same roof height, all that different stuff. So if there was a way that you could, say, take a picture of each of them and then just enter that information once and have it be stored for all of them, and then have separate for the grain information, but the general bin information would be the same for all of them. That would be a nice feature to add as well.
All right, so to conclude, overall, we're happy with our product. at the end of the time. We're happy that we were able to accomplish everything that we set out to do. And on top of that, we were all able to overcome roadblocks. So there's times where we didn't know how to implement a feature that we needed to do. We had an approach, did some studying on that, did some trial and error. Maybe we found that that's not the best way to do it. Maybe there's a more efficient or user-friendly way to accomplish one of our user stories, for example. And we like that we were able to overcome those roadblocks, learn from them, and overall we're satisfied with what we ended up with. Any questions?
I had a couple. First, I'll just say I really liked what you did. That was really good. So one question, you used, it's an iOS application, but you use Xamarin. Did you by any chance try it on an Android to see what would happen?
We have not. as of now.
So for like for information or for location services, for example, we use the iOS specific version of those. So we would get several errors if we just tried to switch it over like right now to Android. There would be several methods that would, if Android do this, if iOS do this, for things like location and camera, for example. So there'd be a few steps that we'd have to take before that. But that could be an easy project for next year or moving forward. It would be a lot simpler to convert it to Android since we use Xamarin.
And I was just kind of curious. I hadn't really thought about the flat, rectangular building. What's the formula for that?
They actually, so they don't collect the height of that building at all, because so that building was more of like had walls and then a peak, but some of them are just domes and they're all kinds of different shapes and sizes. So they actually just they calculate the area, they calculate the height of the green, just multiply those, and then there ends up being a lot of deductions. Like in that picture you saw, there was some like concrete pillars sticking up. Those would be along with the deduction volume and stuff like that.
And lots of uncovered area.
Yeah. Actually, those buildings, a lot of times, if companies have that much grain, they actually invest in the NAU said they're like kind of like laser systems or something that are able to scan the entire area and just calculate the volume for you. So that's, I think that's really cool. But click one button and it's done. But.
All right, thank you.
Yeah.
Yeah.